Hey everyone, and welcome to your 8.5 notes. So 8.5 is all one part here. Okay, we're learning about recursive rules. So far we've learned about explicit rules, which give us the terms of the function based on the position number. So first term we would plug in a 1, second term we would plug in a 2. The recursive rule actually gives us the terms based on previous terms. So if I know the first term is 3 and I want to add 3 every time, then I would take 3 plus 3, and then I would take 6 plus 3, and then I would take 9 plus 3. Okay, so it relates it back to the previous term. So here at the bottom we have how to write the recursive rule for arithmetic. Remember, that is the common difference, so adding, subtracting, and geometric, which is our common ratio, which looks like multiplication and division. So we're going to start by writing the first 4 terms here. So what this tells me right here is this is the first term. So my first term is 5. And then my second term is my previous term plus 3. Okay? So I'm going to take my previous term, which was 5, and I'm going to add 3 to that. And then to take the next one, I'm going to take 8 plus 3, which will give me 11. And then I'm going to take that term plus 3, which gives me 14. So there are my first 4 terms in my sequence. Okay, so you're taking the previous term and you're doing what it tells you to do with it. So this next one, my first term is a 1. So I'm going to say my first term is a 1. And what's happening each time is I'm taking my previous term times 3. So I'm taking 1 times 3. So my second term I have 3. Third term I have 9. Fourth term I have 27. Okay, each time you're multiplying by 3. These two problems look slightly different, but they do work the same way. Remember, on day 1 of chapter 8, we said the domain typically starts at 0 or 1, and to assume 1 unless it says otherwise. So these, it actually says my domain starts at a 0. So this is going to look like a sub 0, sub 1, sub 2, and sub 3, because I'm trying to find the first 4 terms. That's technically 4 terms, okay? So my first one here is an 81. Then it says 1/3 times my previous term. Since those are right next to each other, it's multiplication. So 1/3 times 81 is 27. 27 times 1/3 is 9. 9 times 1/3 is 3. So there's the first 4 terms in that sequence. Okay, same thing for this next one. So I could write these this way. Okay, if I'm plugging them in, then I know this is a 1. That's the one that's given to me. And I'm going to take that plus the term number. Okay, so I have my previous term plus my term number of here. That's 1 plus 1, so that's 2. And then here I have my previous term, which is a 2, plus term number is a 2, so this one's 4. And then previous term is a 4, plus my term number here is a 3, so that is 7. Okay, so 1, 2, 4, and 7. Okay, on the next problems, I'm going to write the first 6 terms. So it does go ahead and tell me the first 2 of them. So I have 3 and 4. And then in order to figure out the next terms, it says add those together. So this is my previous term. And this is 2 before. So if I go back 1, this is like going back 2. Okay, so to get my third term, I'm taking my previous term, which is 4, plus my term 2 times ago, back 2, which is 3, so this would get me 7. Okay, so then I'm going to take my previous term, which is 7, plus 2 back from that was a 4, so this gets me 11. 11, 2 back from that was 7, so I get 18. And then 18, 2 back from that was 11, so this one is a 29. Oops. Okay, for our next problem, again, we are writing the first 6 terms, so it gives me the first 2, 1 and 2, and it says this time I'm going to multiply those together. So 1 times 2 gets me 2, 2 times 2 gets me 4, 2 times 4 is 8, 4 times 8 is 32. Okay, so there would be my list, so you're taking those and multiplying each time by that next number. Right, in the last example on this slide, again, it gives me the first two. It says 5 and -1. And then I'm going to take those and multiply them together according to my rule. So 5 times -1 is -5. Then -1 times -5 gets me a +5. -5 times 5 is -25. And then those two multiplied together, I get -125. Okay, what we're going to practice now is actually writing the recursive rules. So I have both of them up at the top of this page. Those are my recursive rules. One of them, remember, is arithmetic, and the other one is geometric. So it just depends on what is happening to my numbers as to which one you are going to use. So to start these, you always start by saying what your first term is. So for the first example, my first term is 3. Then I have to figure out what is happening each time. So to get from 3 to 10, 10 to 17, and 17 to 24, these are adding 7 each time, so that is an arithmetic problem. So when I write my rule, it looks like my previous term plus 7. Okay, and there would be your recursive rule. First term is 3, you take that previous term plus 7. Okay, second one, I'm going to look and see what's going on. I know my first term is a 1, and it looks like each time I am multiplying by 4. So this one is geometric. So my rule is going to look like a sub n equals 4, that's my common ratio, times my previous term. Okay, my next problem, I am starting with a 5, first term, and I'm looking at my problem and it looks like it's getting smaller, but it's not subtraction. So I know this is division, or remember we are multiplying by a fraction. So this one, I am multiplying by a -1/5, which is like dividing by a -5 each time. So when I write my rule, a sub n equals, I have a -1/5 times my previous term. Okay, and the last one, each time on this, I am going down by 2, so that's a subtraction of 2, that's arithmetic. So my first term is at 10, and my rule says I'm taking my previous term and then subtracting 2. We have 4 more of those we're going to write the recursive rules for. Just remember that when we actually found those terms, there were a couple different ways that we had them. So we had the simple ones where it told us what we were doing each time, multiplying or adding. Then we also had those examples where we were relating multiple terms to each other. So just keep that in mind as we're writing these rules. I think that's one of the biggest things that gets overlooked here, because when I go from 5 to 6 and then 6 to 11, I'm noticing that I'm not adding by the same thing each time and I'm not multiplying by the same thing each time. But I do know that if I take my first term plus my second term, I get 11. So then I'm going to try it, second term plus third term, I get 17. So I know what's actually happening here is I'm taking my first term of 5, and I'm saying my rule is to take my previous term plus the term that happened 2 times ago. Okay, so we just say n minus 2 for that. And those are all in the subscript, so tiny things, bottom of A. Okay. Okay, my next one, I'm going to see if I can do the same thing. Okay, so 2 to 3, I would add 1. That doesn't get me to 6 if I keep adding. If I multiply 2 times 3, I do get 6. 3 times 6, I get 18. 18 and 6 gets me 108. So this time I'm actually multiplying my terms together. Okay, so what's really interesting about these is we have to make sure that we are not just marking our first term. So on this last one, I'm actually missing a piece right here. Okay, because if I just gave you this, you wouldn't know what to plug in. So remember, I have my first term, but on these you also need to say what your second term is. So this one, I have a sub 1 equals 5, a sub 2 equals 6, and then the whole rule. So on this next equation, a sub 1 equals 2, a sub 2 equals 3, and then I need my whole equation. Okay, and this one we said they were being multiplied together, so I'm taking my previous term times the term that happened 2 times ago. Okay, for my next one, I know my first term is a 1. I know my second term is a 2. I'm looking at how they are related. Again, this is multiplication, so I have a sub n equals my previous term times the term that happened 2 times ago, so 2 terms before. Okay, and my last one, I'm looking at how these are related, very similar to the ones on the rest of the page here. So I have my first term is -4, my second term is 1, and this time I am adding them together in order to get my next term. So my a sub n equals my previous term plus the term that happened 2 numbers ago. What we're going to work on next is actually changing the rules back and forth between the two forms. So remember that what we were working with before was explicit, and now what we're looking at is recursive. So we're going to take the old form and change it into this new form that we know. So the old form said this was our term number, so I'm going to go ahead and plug in a 1 here in order to get what my first term is, which is a 10. So my first term is a 10, and then I'm figuring out what's happening each time. So I'm going to take my previous term, and then this is, remember, kind of like your constant or your slope when you think about it like that. So that's what's happening each time I'm actually adding 3. Okay, so that's what your recursive rule would look like. For the next one, remember that this is your first term and your ratio was inside your parentheses. So our first term is a 2. And when we write our geometric recursive rule, remember that ratio goes out front, and then you just multiply by that previous term. Okay, for my next one, again, I'm going to plug in a 1 to figure out what my first term would be. I end up with a -3.3. So first term, -3.3. Remember that that number with the variable is like your slope, so that's telling you what's happening each time. So I'm going to take my previous term and minus or subtract subtract 1.3, okay, or add -1.3. And the last one on this slide, again, this is my first term, this is my ratio. So first term is a 6, and a sub n is 1/2 times my previous term. For the last slide, we are going to change the recursive rule into the explicit rule. So I have the explicit rules written up at the top there, arithmetic and geometric, so that we can work with those. Okay, so on this first one, I'm noticing that this is my common difference. So I know that is the D for an arithmetic problem. So I'm going to take my first term, which is a 3, and add to that n minus 1 times that common difference. I'm going to distribute, so I end up with 3 plus 4n minus 4, and I know that my rule looks like 4n minus 1. Okay, for the next one, I have multiplication happening. Here's some parentheses. That's telling me it's geometric. So I'm taking my first term, and then I have this as my ratio. Remember, ratio is on the outside of our recursive rules. And then I have n minus 1 as my power. Okay, next problem again is geometric because I have that multiplication happening. So this is my ratio. Here is my a sub 1, my first term. So my rule looks like 4 times a -2 to the n minus 1 power. And my last one, this has a -6 on the end. It's not multiplication, so that's my common difference. So I know this one's arithmetic. I'm going to take my first term, which is 10. I'm going to add to that n minus 1 times this -6. Distribute my -6, so I end up with a -6n plus 6 there. And when I simplify that down, I have -6n plus 16 as my rule. Hey, if you guys have questions, make sure you are asking either through email or through Teams, and your assignment is on Clever. Thank you.